6.4 Vectors and dot products. Well, you should learn how to find the dot product of two vectors and use the properties of dot products, how to find the angle between two vectors, and determine whether their two vectors are orthogonal or not. Last lesson we talked about vector addition and vector multiplication. Right, when you got that, you got a vector. But this one we're going to talk about a special product called a dot product. And when you do this, you get a number. So that's the dot product here. So let's say you have a vector u and vector v. All we're going to do is multiply the x values together, u1, v1, and multiply the y values together with u2, v2, and then add them up. That's it. That's a dot product. It has some special properties though. So here's a normal property. These the normal properties of a dot product. Just like any other number, it's associative. If you multiply by 0, you get a 0. All the normal rules we have for dot products. So let's find the dot product of these real quick. So all we're going to do here is multiply 4 times 2 plus 5 times 3. And you get 8 plus 15, which is 23. Over here we're going to get 2 times 1 plus negative 1 times 2. 2 plus negative 2, which is 0. That is a very special property. And when you get a dot product, that means that they're going to be perpendicular. The two vectors are going to cross at a perfect 90-degree angle. We have a word for that in vectors called orthogonal. That means it's a 90-degree angle. So that's like a special result. When you do a dot product and you get 0, we'll talk more about this, but it means that those two things are 90 degrees, they're perpendicular to each other, also known as orthogonal. This one here, 0 times 4 plus 3 times negative 2, 0 plus negative 6, 7 negative 6. That's a dot product, right? A very simple operation is multiply the x's, multiply the y's, add them up. Using the property of dot products, use the vector properties to do these things. So u dot v, so we're going to dot u and v here. So here's u, here's v. So we're going to go negative 1 times 2 plus 3 times negative 4. Afterwards, we're going to multiply that by w. So this is a. So we're going to get negative 2 minus 12 times w. So negative 14 times w. Now w is 1, negative 2. So this is going to be like negative 14 times 1, negative 2. So we're going to get negative 14 and a positive 28. So that's what that times that is, right? So you do the parentheses first, and then you simplify w as this, and it's just a number times a vector. So you make it bigger. B u dot 2v. Well, first let's do the 2v. 2 times 2 negative 4. So that is 4 negative 8. We're going to dot that with u, which is negative 1 and 3. So once you do that, you just dot product. Multiply the x values together, negative 1 times 4, plus multiply the y values together. Negative 4 minus 24, negative 28. C. So magnitude of u. So we could find magnitude of u two different ways. So the magnitude of u, we use the formula, which is just negative 1 squared plus 3 squared. So it's going to be 1 plus 9 square root of 10. That's the normal way to find the magnitude of u. We have the formula that's a squared plus b squared. That's the normal way. Another way, an alternate way, is this formula up here. Dot product is the same thing as taking magnitude squared is the same thing as taking the dot product by itself and square rooting it. Like if we square root this, you get the magnitude. So we can also go square root of u dot u. So that's going to be negative 1 times negative 1. Right, you multiply the x values together. So negative 1 times its x value plus 3 times 3. So I'm going to get 1 plus 9, so square root of 10. So you could either do the dot product itself and get the magnitude, or you could do the normal formula. How about the angle between two vectors? So this is where dot product comes in handy. So if we want to find the angle between two vectors, and that's when we do that, we're talking about tail to tail. Like that. That's the angle between two vectors. So when two vectors are going opposite directions and their tails are not, it's tail to tail. We can find the angle between those two vectors by using this formula. Cosine theta equals u dot v over the magnitude of u times the magnitude of v. That's it. Let's do an example real quick. So if I want to find the angle between these two vectors, it's going to be u dot v over the magnitude of u and the magnitude of v. So So let's find u dot v first. So that's going to be 4 times 3 plus 3 times 5. So that's going to be 12 plus 15, so 27. Now we need to find the magnitude of u. And the rest is a formula, which is you do the first term squared plus the second term squared. So 4 squared plus 3 squared. So magnitude of 16 plus 9. Square root of 25, which is 5. Magnitude of v, same formula, just with v. So 3 squared plus 5 squared. 9 plus 25. Square root of 34. Now let's put this all into the formula. So we have cosine theta equals 27 over 5 times square root of 34. Right, and if I want to find the angle between it, we're just going to do cosine inverse. In a calculator, we'll do second cosine. I'll do this without putting the fraction button. 27 divided by, I'll make sure these are together, so I'll put parentheses, 5 square roots. Oops, didn't hit square root. Second square. Oh my. Second time. Second squared 34. And we get 22 degrees. And that's how you find the angle between two vectors. Now, two vectors are orthogonal, which just means perpendicular. It's a fancy word for it. Right, so that means that they cross at a 90-degree angle if the dot product equals 0. So if I want to tell are these two vectors orthogonal or not, all I'm going to do is take the dot product. If it equals 0, then they're orthogonal. That means to make a 90-degree angle. So let's do the dot product with these guys real quick. So 2 times 6 plus negative 3 times 4. I get 12 minus 12, which is 0. So yes, these two things are orthogonal. So u is perpendicular to v. They're orthogonal to each other. That's the lesson.